Good morning, friends. This is a series of lecture for TYPC Analytical Chemistry Semester 6 student. Here the chapter number 6, Flame Emission Spectroscopy. And now in this lecture we are going to study the problem based on the flame emission spectroscopy. Now here the statement of the problem is calcium was acid by FES. Enough standard is added to standard solution of calcium and to make the analyte to make of each solution containing 250 microgram per ml. After aspiration of each solution into the flame, the emitted intensity of the calcium line was measured at 422.7 nanometer and the strontium line at 460.7 nanometer. Determine the concentration of calcium in the sample, and the table is given. First of all, here the calcium was acid by FES. Enough standard is added, that is lithium which is used as a standard here. Now for this problem, calcium and strontium, these two samples are given, and this method is based on the, we can say, standard addition it is a calibration curve method. Now here two line, that is the calcium line at 422.7 and the strontium line at 460.7 nanometer is given, and we have to determine the calcium concentration from this sample. Now concentrations are taken in microgram per liter of that calcium. It is 2, 4, 6, 8, 10 and sample concentration is there. And here relative intensities have measured at two lines, that is 460.7 for strontium and 422.7 for calcium, and we get the readings like this. So how this problem will be solved? We will use this we will solve this problem in Excel. So here Excel file is given, and these readings have already I have put up in the form of table in Excel. The concentration of calcium, which will varies from 2, 4, 6, 8, 10 with sample, and these two lines, that similar table we have already read in Word file, and in Excel file that similar table I have put up with their values. And the last table, or we can say last column, that consists of the ratio or relative intensities I 422.7 dash, or you can say divided by I 460.7, that is intensity of two ratios, that is relative intensities. So for that purpose, let us solve this problem in the stepwise manner. So here we take the ratio of this first, and then at the denominator line this strontium line is given, because here 460.7 appears here and 422.7 appears at the numerator. So we take this C column at the row 5, that is C5 divided by B5. So this is a selection of different columns, that is C for calcium and B for the strontium, which will get selected, and we press the enter button to know the value. Directly it will come the answer 0.772. So this is the first answer. We drag this line and we get the answers of the corresponding intensities, relative intensities for calcium and strontium line. So this is our y-axis and this is our x-axis. So we get the sample intensity, relative intensity, that is 1.87, and we get the known concentration, that is 2, 4, 6, 8, 10. with different values. So this is the y-axis and this is the x-axis. So let us solve this problem with the graphical method or standard addition method, or you can say calibration curve method, by taking polynomial function or linear function, not a polynomial, it is a linear function. So we select the simply here we selected first line, or you can say first column for the x-axis. Press Ctrl button and then drag the D column for y-axis. In the insert tab we have the scattered, we have this type of, you can say, insert scatter xy bubble. So we have the nature of the graph that will goes in this direction. So simply here we get the graph, and what should be the answer? Let us go add trend line. If we add trend line, there is a linear, point out this linear and then display equation on the chart. So this will be the equation for this line, and this will be the nature of trend line, and this will be the slope that will goes to 0.3792, and this is the intercept value. So y is equal to mx plus c. This is the nature of the graph, and here m corresponds to that is a 0.3792. Now here y-axis, on the y-axis we have the values 1.87. So we have the values 1.87, and the slope is 0.3792. We have to calculate x-axis because we have to calculate the concentration. We have to calculate the concentration. For that purpose we should divide y, that is y value, that is a 1.87, divided by that slope, that is 0.3792. Therefore the answer should be here. So is equal to, the values were 0.3792. we get m is equal to 0.3792. we have the y value for the unknown concentration, that is 1.87, and the answer should be, simply we have to divide 1.87 divided by 0.3792. So the answer should be here. Let us divide in Excel 1.87 divided by 0.3792. The answer is 4.93. So here we have the answer 4.93. So the answer is 4.93. It is in microgram per ml. Therefore the unknown concentration, that is calculated from the graphical method or using Excel as a software is 4.93. So we can say I will again take the revision. Concentration is given from 2 to 10. Strontium and calcium intensities are given. We just go to the Excel, we just put up or set up that table accordingly, and we take the ratios by dividing this calcium line to strontium line, and after that we calculate these two values we calculate this concentration of unknown sample by taking the linear regression or linear function by setting the slope that we get the line y is equal to mx plus c. Here the m is 0.3792 and just y get divided by 0.3792. Y means here unknown concentration, so 1.87, that should be divided by 0.3792. we get the answer 4.93, and we just put up that answer in Microsoft Word file of the problem. So with this content I conclude this lecture. Thank you very much for your patience listening.